Our next speaker is Causation from the City University of Sao Paulo in Brazil, the College of Medicine.
Well, good afternoon, ladies and gentlemen. Today I'm going to talk about causation in clinical neurotoxicology. The idea of cause and effect plays a constant role in our everyday lives, and why not say in the practice of toxicology. But anyway, what is causation? Is it part of the natural order of the universe, or simply a mental construct we use to make sense of what happens to us? After centuries of philosophy, various thinkers could not solve this fascinating dilemma. But anyway, let's go direct to the point. How do we determine causation in clinical neurotoxicology? Well, I made some extensive research through some textbooks, excellent textbooks, by the way, and I found out those causation criteria for identification of human neurotoxicity postulated by Schomburg. I'm not going to read them, but I'd like to stress out the last one of them, in which he said that the development of a satisfactory corresponding experimental model is absolute proof of causation. Afterwards, he points out cardinal tenets of neurotoxic disease, and again, he points out that the development of an experimental model is absolute proof of causation. But, as a matter of fact, we already know that this is not completely true. Experimental toxicology studies are not automatically considered absolute proof of causation. I also found out this very interesting algorithm for the diagnosis of human neurotoxic disease by Professor Feltham, very inspiring professor, by the way. And as you can see, the diagnosis of neurotoxic illnesses are only made after excluding other possible causes. On this textbook, we can also find the Boston University Environmental Neurology Assessment. And again, you can see a very beautifully designed protocol that establishes high scientific standards for evaluating neurotoxic exposure. But these current valid criteria for identifying human neurotoxicity are not totally new. As a matter of fact, they're strongly inspired by the work of Sir Austin Bradford Hill, which almost 50 years ago had already postulated the criteria, the famous Bradford Hill criteria for causation. But why does it matter? Why am I talking about it? Well, I'm going to give the example of DDT. This photograph shows some malaria workers in Uganda, which claim that DDT is a weapon of mass survival. And it can sound very shocking for us, but we must understand the burden of malaria in the world in terms of morbidity and mortality. It's very important to remember that Plasmodium is a protozoan that causes malaria, and it is transmitted by a vector, the Anopheles mosquito. Ultimately, it destroys red blood cells. And we also have another very interesting mosquito, that the Aedes aegypti, that transmits dengue and yellow fever. And these are some Brazilian workers from the western part of the Amazon that claim that more than 50 colleagues have died as a consequence of DDT poisoning. This is a patient of mine who has also had a history of exposure to DDT and other pesticides. He worked for the tobacco industry, he was an instructor for new applicators, and he stored tons of pesticides, especially DDT, in his home. His wife was responsible for washing his clothes, and as a matter of fact, recently we found out that DDT metabolite was very, very high in his serum, approximately 1,000 times more than the median of Brazilian population. And he had 2 heart attacks. He had deep venous thrombosis. He had gynecomastia. As you can see, he had this huge mesenteric lipoma. His son was born with cryptorchidism, and his wife has recently died of renal failure. We can make a lot of assumptions and hypotheses on the physiopathology of DDT in this case. But keep those cases in mind. I will come back to them later.